In a world where the moon covers the sun and darkness shadows the land, Dr. Anderson's senior honors physics captured it all during
There was this total eclipse of the sun.
Oh, I didn't see you there. My name's Emerson, and I'm a member of the seniors physics class. We set out to determine what environmental factors were affected by the moon's shadow. We studied sound, UVA, UVB, temperature, light, pressure, and magnetic field. This is our data. And these are our stories.
Have you ever walked into the senior physics lab or literally any Marici classroom and noticed how much darker and colder it gets? Well, that's kind of what happened with the eclipse.
Though totality didn't occur until early afternoon, we started recording data at 9:20 a.m. On the top of the screen, we have a time versus light graph. You can see how about after 4 hours after we began collecting data at 1:18 p.m., totality occurred. Light remained relatively constant until the moon covered the sun. On the bottom of the screen, we have a time versus temperature in degrees Celsius graph. Taking a closer look at the graph, we also determined that the temperature dropped almost 10 degrees Fahrenheit. You can see as the day went on, the temperature increased as it usually does, but there was a definite dip in temperature at about the same time the light decreased. After totality, the temperature began to rise to normal temperature for an average August afternoon.
We studied temperature and pressure changes during the eclipse. We have temperature data, but unfortunately we have no quantitative data to support there was a change in pressure. We can still rely on empirical evidence though, which does suggest that there was a change in pressure during the eclipse. The pressure inside my water bottle was higher than the pressure outside. Therefore, the water moved from inside the water bottle to the outside. And did any of you notice your ears popping during the eclipse?
Did you notice a change in the wind?
We did.
A change in wind speed and direction is actually because of a change in atmospheric pressure. So if you're able to feel a breeze, it's probably because the pressure outside was changing.
And ears pop because your inner eardrum has air trapped in it. And when atmospheric pressure changes, it puts pressure on your eardrum.
So, as you can see, ears popping, the wind, and Natalie's water bottle could all explain a change in pressure during the eclipse.
Did you notice that you felt heavier during the minute and 14 seconds of the total eclipse? You probably didn't. But according to our study of the gravitational pull during the eclipse, you were, in fact, slightly heavier. The closer the moon is to the Earth, the stronger the gravitational pull is. This graph shows an increase in gravity during the eclipse. We are not sure if this increase was an eclipse phenomena or if this occurs during every full moon. Further research would need to be conducted to answer this question. So, did you feel heavier because you bashed at your advisement party, or was it because of an increase in gravitational pull? Maybe both.
Hi, today we're going to
Maggie, camera's over here.
over there.
Yeah, right here.
Hi, today we're going to tell you about the magnetic field during the total solar eclipse.
Figure 1. Not drawn to scale. So here's the sun, here's the earth, and here's the moon during the eclipse. Here's the earth's magnetic field, here's the sun's magnetic field, but it goes on much farther than just the earth. And this is the magnetic field, but the moon is blocking it from the sun to the earth. The bottom graph is the graph of the magnetic field. The light graph has been placed on top to show the moment of totality during the solar eclipse. It took some time for the magnetic field sensor to warm up and show the normal magnetic field of Ursuline. The slope began decreasing as the solar eclipse began at about 11:45 and continued to decrease through totality. After totality, the magnetic field slightly began to increase for the remainder of our data collection.
I'm Brooke.
I'm Kara.
Go.
And we're here to tell you about how sound pressure changed.
Before conducting this experiment, we predicted that the insects and birds would begin to chirp during the partial eclipse, but during totality they would become silent, much like they are in the middle of the night. Just like insects and birds begin to chirp again at dawn, we predicted that the insects and birds would get louder as the partial eclipse began again.
Because we were measuring the sound level of insects and birds, we thought that it would be a good idea to conduct the experiment near Ursuline's prairie. While this provided good data on the birds and insects, we were often interrupted by the sound of trains nearby.
They came at 11:56 a.m., 12:47 p.m., and 1:23 p.m. If you look at this graph, you can see slight increases in the amount of sounds as the trains came by. The sound level was also affected when the students coming onto campus for the first time at noon, as shown by this increase in the sound on this graph.
However, we learned a few things from the lab. Next time we should not put our data near a train where everyone will gather to watch.
For the Honors Physics class of 2019, you can learn from our mistakes when the total eclipse happens in South America. You might want to work on your Ursuline connection with our sister schools down there.
Maggie Fix here, coming in live from Oakland with a PSA.
During this past eclipse, UVA and UVB rays were very present, and without those glasses, you could be suffering from eye damage, disease, and or wrinkling. UVA rays are the worst of the worst and can cause serious damage. UVB rays can cause short-term damage, like a bad sunburn or blurred vision. Now off to Ashley Seven from Marici Labs.
Oh, we're live. Thanks, Maggie. Today we'll be reviewing the light levels, UVA, and UVB graphs from the past solar eclipse. The light, UVA, and UVB graphs all follow a similar pattern. The decrease begins at the start of the eclipse, leading down to totality, and finally back up to regularity. Back to you, Maggie.
Well, that's a wrap, folks. I'm Maggie Fix, signing out. We'll see you next time.
For each of these experiments, data is inconclusive because we did not test before or after the eclipse under similar circumstances with the moon in its position.
There was this total eclipse of the sun. It got very dark.